Hi, so we're going to continue the tutorial. In the first tutorial what we've done was we have created a folder. We have put different files associated with the tutorial, such as the script and the datasets within the same folder. And then we created a project within the RStudio associated with that folder. We'll do a quick recap of what other things we can do. So this is where we have stop last time. The first thing that would be good is to check whether our working directory is still the one we're interested in. And we can see that it is still in the folder tutorial 1, so the folder that I would like to be associated with this session. And I have my script 1 loaded over here. It's a file with the R extension, and I have loaded it by clicking on this icon before and loading the script, but I'm not going to do it right now. So one of the things we did in the first tutorial was we installed packages that we require for the analysis, and then we loaded those packages into the space. So we're going to load the Igraph package again. And we're also going to load the Igraph data package that we have previously downloaded into our machines. And then we're going to load the data that's a part of the Igraph. This is the data that you've been working with before. And we will make sure that we have the US airport data set. We've learned how to run the command to see some basic information about this data set. And so what we're going to do today is look at some basic analysis that could be done over a network in Igraph. So one of the things we could start with is looking at the edge density. So that would be a function, a command of edge density run over the network object called US airport. So I'm going to run that by highlighting it in the script and pressing the run button. And it gives me a number, and that number is 0.04. So 0.04 is the density if I round it to decimals. What that means is that out of 100% of all possible ties, we only have 4% of ties that actually exist within the network. Another important metric within that we can also look at is calculating the degree. That is done by running function degree over the object of interest. So here it would be degree US airport. And what this returns, it returns a vector where each of the nodes, here remember the nodes are the names of the airport, has a number, and that number represents the number of ties adjacent to the node. You can do a number of things with this vector because it's numeric, such as you can look at, for instance, the mean degree, and that tells us what the mean degree of sort of out of all degrees existing. What's the mean of that? In the same way, you may be interested in actually look at the median. So we'll just look at that. You would know that in some cases looking at the median degree is more interesting in a network dataset because of the degree distribution. And so we will look briefly at maybe degree distribution. So that's, let's see if this is going to, no. Right, so one of the things we could do is look at the histogram of degree, and to do that we would want to run a command called hist over a vector that's derived by running a command degree over a network object. In other words, a histogram command over this numeric vector, and that should produce an image. Right, so that shows us there were a lot of people with a low degree. Oh, sorry, I have a lot of nodes with a low degree and few nodes with very high degree, which is quite typical. We can also look at the summary of degree. That would be something like that. So what that does is we're taking command summary and running it over the numeric vector that is produced as a result of running function degree over the US airport network. So in other words, this is a summary of this vector here, of these numbers, right? So we know that the minimum degree in that is 1 and the maximum is 1700. We know that the median is 13, and we knew that before because we calculated that vector. We also know the mean, which we could have calculated as a separate function here. We could also look, well, that's not so interesting because we know the length of the vector. Right, so one of the important things that you may want to do once you conduct those calculations over, so once you run your function degree over the network, you produce a vector, but this vector exists separately from your network. So what you may want to do is assign an attribute to a node that would give you the value of the degree. So to remind you, if I just retrieve the information about this network, we have some attributes here. So we know that, for instance, vertices, right, nodes. We know the geographic position, that's an attribute for each node. We know things like cities where those airports are located, that's attribute of a node. So what we want to create right now is yet another attribute that is the number that stands for the degree of the node. And to do that, we can use a command that looks like that. So what we're doing is we are creating an attribute called degree on the vertices of a network object US airports. And so this will create this vector as a part of the network. And to fill in the values in each cell there, those values will be derived from running a command degree over the networked object US airports. In other words, this command here on the right creates that numeric vector, and this command here on the left assigns this numeric vector to a new vertex attribute of the network US airports, and the name of that attribute is degree. So I can run this, and to check it, I'm just going to run and check the name. I'm going to ask to call out for the name of the attribute degree, and it gives me this vector that we had before, which is exactly the same as this one. It's just that we do not get the name of each independent airport because in reality each of these is tied to that in a larger data frame. So let's continue. In the same manner as you have created this attribute called degree, you may want to do other things. So we know that there are in degrees depending on incoming ties, so we can count the number of ties that are coming into the node. We can also count out degree, which is the number of ties that are going out from the node to other nodes. We can also count betweenness centrality or closeness centrality. These are things that we have done. If you look at your extended nodes, you can read up on the meanings of these metrics. So they are created as attributes of the network in the same way as we have just looked. By running a command degree over the US airports network object, we just specify that we are interested in the in degree or whether we're interested in the out degree. So I'm going to run this line of command to create the attribute called in degree, and then I'm going to run this line of command to create a vector called out degree and attach it to the vertex on the network US airports. I'm also going to calculate betweenness for all the nodes and create an attribute out of it called betweenness, and I'm going to do the same thing for closeness. And just to make sure that I have done everything correctly, I can check my network object, and you will see that now when I retrieve the network information, there are new attributes here called degree, so it's numeric, and for it's a vertex attribute. So it's the same for betweenness and the same for closeness. So these are new things, as well as an in degree and out degree. But I may be interested in conducting statistical analysis with these. I can do that in R, or I can export those calculations out of R Studio into and use as a CSV file, and then import that into SPSS or Excel. To do that, I'm going to create an object called node attributes, and that object will be a data frame, and the content of the data frame is going to be a set of vertex attributes that I'm going to take out of the US airports network. In other words, I want to take all this information that relates to vertices and create a separate file, a separate object that I can use within RStudio, or that I can export and do things with, and that object names is node attributes. So I'm going to run this command, and that created a file called node attributes. If you remember, there are different ways of looking at what's inside this file. So this is one of them. It tells us there's a data frame. It has 755 observations, different variables. So there's a column called name, column called city, position, that tells us the type of the variable, different levels, and we know that these are all numeric because we have created them. So we can also use this command here, to look at the data frame within our Studio environment. And if you're lazy, you can just click on degree here and sort things out and see, well, this is the airport with the highest degree, or this is the airport with the highest in degree. So Atlanta is the one where most connections come into, and it is also the one where most connections go out from. And the airport with the highest betweenness, however, is Anchorage, Alaska. So that's the airport where that sits on most paths between other parts of the network. So it's a lot of air flights go through. And for closeness, we can see that Chicago is one of those most interconnected airports. And if you remember the little tutorial we did in the beginning, where we saw that Chicago and Minneapolis, and I don't remember what was the third city, were the three airports with the highest connections with one another. So that could be one of the reasons why the closeness of Chicago airport is so high, because it's also highly interconnected to other highly interconnected airports. So in that sense, it's close to the hubs, which makes it closer to other nodes. But going back to our script here, so what we may want to do is we may want to export this object node attributes that we just looked at as a CSV. For that purpose, we're going to run write CSV over node attributes, and we're going to call that file that we're creating, we're going to call it node attributes CSV. So I'm just going to run that, and if you remember, it's going to write into the directory associated with my workspace. If when you run get working directory, if whatever directory comes out is not the folder that you're interested in writing this into, you can always change that in here, session set working directory, choose directory, so you can always specify that without actually writing a code. It's an easy thing so to change. But in my case, I have written the file out, so I'm just going to go directly to a folder to show you that in fact, here we go, this is my CSV file, and now it's ready to be put into other software for the analysis.